now going to start basic nomenclature of chemical compounds, how we name compounds. And we have this sort of a strategy here, a schema that we're going to approach. The first question we ask is our compound ionic or covalent? Okay? If it's covalent, it has classical molecule with bonds. If it's ionic, it forms a crystal structure with positive cations and negative anions growing in three-dimensional space. Now there are two types of ionic compounds. Binary compounds, which are between two types of elements, and this requires a metal and a non-metal. The metal loses an electron and becomes a cation. The non-metal gains an electron and becomes an anion. Or it could be a polyatomic ion, which is a molecule with a net charge. Ammonium, NH4, is a polyatomic ion. Sulfate, SO4 - 2, is a polyatomic ion. So we have to memorize the names of these. Then we have two types of metals. We have some metals that only have one oxidation state, and we don't have to identify it. Then we have a second type of metal which has various oxidation states. The oxidation state is like the charge, okay? And therefore we have to state it. So iron has two charge states. It has an iron +2, which is also called ferrous, and an iron +3, which is called ferric. Okay, now if the molecule is covalent, we have two types of covalent bonds. The first type is the classical molecule, like carbon dioxide, sulfur trioxide, and we use Greek prefixes. The second type is when it looks like an ionic compound in its structure, but instead of having a cation, it has a hydrogen. But the hydrogen can't lose its electron and form a positive charge ion, because that leaves a subatomic particle, a proton in the nucleus left behind. So it has an unequal sharing, and the name of the acid will be based on the name of the salt that would have formed if, say, it had a cation instead of hydrogen.